Our last two lessons were about understanding logarithms and looking at two special logarithms, the common logarithm and the natural logarithm. In this lesson, we're going to look at graphing logarithmic functions. So to do that, we're going to remember what an exponential function looks like. And remember that if I have a function, f of x equals some number a to the x power, and a has to be positive and cannot be equal to 1, that I'm going to have three ordered pairs on that graph. When x equals -1, y is a to the -1, or 1 over a. When x is 0, a to the 0 power is equal to 1. And when x is 1, a to the first power is equal to a. So depending upon what our base is, our base a could be 2 or 3 or 5 or 10 or e or whatever, we have those three ordered pairs. We always have the point 0, 1. We have the point 1a, whatever a is, and then we have our fraction here, 1 over a, and we know what our basic exponential shape is. Like that. And we know that we have a horizontal asymptote at y equals 0, and that our domain is -infinity to infinity, and our range is 0 to infinity, not including 0. So you can review that in the lesson on graphing exponential functions. What does this have to do with logarithmic functions? Remember that a logarithm is the inverse function of an exponential function. If I have y is equal to a if I have n is equal to a to the m power, that's the same thing as saying the logarithm base a of n equals m. So the logarithm is equal to the exponent. That tells us that if we have the function g of x, which is equal to the logarithm base a of x, it's going to be the inverse of this function. It's saying, what power would I take a to get x? And remember when we did our lesson on inverse functions, that if we have a set of ordered pairs on a function, to find the inverse function, we can just switch our x and our y. If I were to write each of those out, I would be saying the logarithm base a of 1 over a, the logarithm base a of 1, and the logarithm base a of a. Pause for a moment and evaluate each of those three statements. And we see that we have a to what power equals 1 over a? -1. A to what power equals 1? 0. A to what power equals a? which is 1. And that's exactly what we have here, our 3 ordered pairs. If I plot those 3 ordered pairs on my graph here, I have 1 over a. I don't know what a is, but it's some fraction, 1/2, 1/3, 1/5, depending upon what my base a was. So when x is equal to 1 over a, y is equal to -1. When x is equal to 1, y is equal to 0. And when x is equal to a, y is equal to 1. So that gives us these 3 ordered pairs on my graph. And remember, when we looked at our lesson on inverse functions, we saw that we had a reflection over the line y equals x between a function and its inverse. So if I draw my inverse function here, I see that it looks just like this. We also can see that we have a vertical asymptote right here at x equals 0. Go ahead and write the domain and the range of that red graph there, the logarithmic graph, based on looking at the picture. And we see that my domain is 0 to infinity, and my range is -infinity to infinity. Let's talk about the domain 0 to infinity for a minute. What that's telling me is if I have any basic logarithmic function, let's say I have logarithm base 5 of x is my function. The x's that I can plug in have to be positive numbers. Let's see what I mean here. If I say logarithm base 5 of, say, -25, I'm saying 5 to what power equals -25? That's not possible. I cannot take 5 to any power, even an irrational number, and end up with a negative answer here. So I can't do that. I can't take a logarithm of a negative number. And we can see on our graph that we do have our domain 0 to infinity. Let's do an example of this with a base. What we're going to do is we're going to graph f of x equals the logarithm base 5 of x. I want you to write the 3 points. And in this case, we're seeing that my y value is -1, 0, or 1. I want you to write what x would be to give that y value. And if you need to look back and review what we saw here, you can do that. Write those 3 ordered pairs, and then draw your graph. All right, so what we saw here is our base is 5. So if I put a 5 here, logarithm base 5 of 5 is equal to 1. Logarithm base 5 of 1/5 is equal to -1. And we always have 1, 0. So I plot those on my graph here. One-fifth is about here, -1. 1, 0. We'll always have the point 1, 0 on any basic logarithm, and 5, 1. All right. Now that's not enough information to draw the shape. So I have to memorize that my logarithmic shape is the one that's sweeping up along the y-axis and then curving out to the right. And that is always going to be my logarithmic shape. And I know that I will always, when I have a basic non-transformed logarithmic graph, that I will always have a vertical asymptote here at x equals 0. And I know what my basic shape is, so I can draw my curve. In our next video, we're going to look at graphing the basic graphs and look at some examples of natural logarithms as well. And we're going to do some transformations.